In the videos in this series, we've been discussing how to take an equation which is written in standard form, find its slope, and then find the equations of lines that are parallel to the given line. We've also discussed how to find the slope of a perpendicular line. So just to refresh our memory on some of what we've done so far, the slope of the given line, 3x plus 4y equals 12. Okay, the slope of that line will be negative because the sign between the x and y terms is positive. And in our fraction, in the numerator, we write the coefficient of the x term, which is 3. In the denominator, we write the coefficient of the y term, which is 4. The slope of the perpendicular line will be the negative reciprocal. Since the slope of the original line is negative, the slope of the perpendicular line will be positive, and then we take the reciprocal of 3/4, which is 4/3. So we have 4 in the numerator and 3 in the denominator. Now, in this video, what I'd like to discuss is how do we take that equation, the equation of the perpendicular line, and write an equation of a line in standard form. Now, for this new slope, we know that the numerator is going to give us the coefficient of the x term, and the denominator will give us the coefficient of the y term. So that means that the coefficient of the x term is going to be 4, and the coefficient of the y term will be 3, and then that will be equal to some number c. However, you'll notice that I left out the sign. Now, since the sign of this perpendicular line is positive, we know that the sign here has to be the opposite of that, which is negative. So look carefully at the left side of each of these equations. If we have the equation 3x plus 4y equals 12, looking at the left side of the equation, we had 3x plus 4y. To show the negative reciprocal slope, notice that what we did was we swap the coefficients. So in the original line, 3 was the coefficient of x. It now becomes the coefficient of y. And in the original line, 4 was the coefficient of y. It now becomes the coefficient of x. And then the other thing that we also do is we change the sign. So in the original equation, the sign was positive. In the new equation, the sign is going to be negative. So we can go from the left side of the original line and write the left side of the perpendicular line. And we're going to do 2 or 3 more examples of this. In this example, we have the line 5x minus 3y equals 9. So to get our perpendicular line, remember we swap the coefficients. And so in our perpendicular line, the new coefficient of the x term is going to be 3, and the new coefficient of the y term is going to be 5. And then what we also do is we change the sign. So the original sign was negative, so the new sign is going to be positive. And so for our whole set of perpendicular lines, we're going to have 3x plus 5y is equal to some number c. Again, we swapped the x and the y coefficients, and we changed the sign. Let's do another example. And so in this example, we have 4x plus 7y equals 28. So once again, we're going to swap the coefficients. And then we're also going to change the sign. So let's go ahead and do that. So that means that we're going to get 7x minus 4y equals c. So once again, just to reiterate all of this, okay, the left side of the equation, when the line is written in standard form, the left side of the equation gives us the slope of the line. Okay, and so to get a perpendicular line, we have to swap the coefficients. In other words, what was the x coefficient now becomes the y coefficient. What was the y coefficient now becomes the x coefficient. And then we also change the sign. If the sign was originally positive, it changes to negative. And if the sign was negative, it changes to positive. And by doing that, what we're doing is also changing the sign of the slope. So I hope that you find this helpful. Okay, this is another simpler way of writing the equations of perpendicular lines.